Okay, I need to amend what that I said on 4 because I realized that I left something out, so I need to fix this. Is 2018 number 1, part 4, or actually it's part EIV. So I'm back to this. And it says, assuming that the sphere is a height 1.4 at time 0, calculate the velocity of the sphere just before it strikes the pad. So I'm looking for that velocity, which we said was 11.5 t minus 0.524. That was our velocity equation that we had. That was 11.5 t minus 0.524. So I'm going to go back to that position equation. The y is equal to 5.75 t squared minus 0.524 t plus 0.080. And this little nugget here is what I need to remember, that I forgot that we had an initial position that we were at. And so what I need to, or actually this is more like a final position, this is like where I end up, but anyway, we'll go back to this equation. We could say 1.4 is equal to 5.75 t squared minus 0.524 t plus 0.080. I can subtract that 1.4 and I'm going to get 5.75 t squared minus 0.524 t minus 1.32 is equal to 0. And then I can put that in the quadratic equation. So that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. And so let's run through the calculations of that. So 0.524 squared minus 4 times 5.75 times negative 1.32. I'm going to take the square root of that. So I get 0.524 plus or minus 5.53 over 11.5. Well, I'm looking for a time in the future, so I'm going to add these two. So plus 0.524 divided by 11.5. And so I find the time that it takes to do this is 0.53 seconds. So I plug that in here. So 11.5 times 0.53 minus 0.524. So 11.5 times 0.53 minus 0.524, and I get a velocity equal to 5.57 meters per second.